Good afternoon, everyone. First of all, I want to thank the guys from NodeOne, Han and Santosh, for having us, for having this great conference. Okay, this is the panel for infrastructure and security. Maybe we can introduce yourself, a little bit of introduction for people that don't know you in the live stream. So maybe Richard, you can start.
Sure, thanks Matías. Hello everybody, I'm Richard Reiner. I'm chairman of EOS Canada. You might ask, what is the chairman doing sitting here on a security and infrastructure panel? I come from that world. I have, over the last 20 years, I have built and sold, depending on how you count, 3 or 4 or maybe 5 cybersecurity companies.
Hey everyone, I'm Igor, head of technology from EOSRio. We come from Brazil. Our goal is primarily with infrastructure and security of the network and enhancing EOS to the maximum.
So just to add to that, you all should know that everybody who's doing BP technology stuff, when we have questions that we can't answer, the guy we go to is Igor.
Okay. Thanks.
I'm Eric from EOS southwest of Eden, or EOS Sweden. Sorry about that. Yeah. Yeah, we had our name stolen, so we had to change it, basically. Yeah. More about that later, maybe. Anyways, I am the CTO and co-founder, and also a part of the Ghostbusters infrastructure and security team with Igor. Yeah.
Eugene, Luzgin. I'm a technical founder of EOS Tribe. I have about 20 years of software development, and I have built and architectured systems for banks, including Federal Reserve Bank, specifically around security. And I'm also a member of Ghostbusters core team, and this group basically, and we worked on security standards for EOS block producer infrastructure.
John Milburn, I'm Gem on Telegram. I've been doing security and internet infrastructure things for about 40 years, built a lot of the broadband internet and commercial services here in Korea.
Okay, good guys, thanks for the introduction. And to start with, maybe with Gem, what are the security responsibilities of a block producer, and how do you see this?
So first, I'm not a block producer. Everyone else here is. I've been engaging with and helping, lots of block producers, anybody who asks questions. But the security responsibilities, very simply, are, stay up, stay producing. The job is really simple, is, make sure that you are as immune to attack and as immune to failure as possible.
Richard, do you agree with that?
I agree with that, John, but I mean, I'd go further. I see the block producers as the organizations more than any others that are responsible for the continuous and the correct operation of EOS as a platform. And that gives you a set of responsibilities that are very similar to those that any organization that's running some other kind of critical infrastructure, whether that's a control system for a power plant or whether that's a banking network or whatever that is, would have. So that's a pretty broad and robust set of security mandates that you've got to fulfill. You've got to think about it in terms of personnel security. Each and every person who has access to infrastructure or to keys, how much do you know about them? Have you checked the backgrounds? Do you know they don't have a history with organized crime or whatever it might be? You've got to think about it in terms of processes and procedures. How do you generate keys? The wrong way would be to generate keys on board somebody's personal laptop, which has some percentage chance, maybe large, maybe small, of already being subverted, and so those keys are not under your control from day zero. It goes on. You've got to think about physical security, you've got to think about network security, you've got to think about application level security. It's a big responsibility.
And without having those issues addressed, what do you think are the main threats for the whole network in case of a security breach on a majority of block producers? Do you think that we can get to a point where the network could be stopped, or what's the worst scenario that you can imagine?
Question for me? Okay. Okay. So I think an awful lot of good quality thinking has been invested in considering network and server level and network architecture and things like that. The things that concern me the most would be, so that's an area where amongst block producers, we have a high level of diversity. The heterogeneity helps us. We're running in all kinds of different ways. We are not identical. We are identical at the software layer, at the application layer. That is a monoculture. We are all running more or less the same applications. And so if there were to be, the most devastating situation would be if there were a scalable attack. If there's an attack that somehow subverts every block producer's operations, and the only way really you could do that would be with an application layer attack. If there is some rogue transaction that everybody signs off on because it's the result of something incorrect in NodeOne. I mean, that's the worst case scenario, right?
Okay. Igor?
Oh, yeah, vulnerability on the smart contract level would be the worst thing for now. So we can't do much to protect for that except for testing every day, every single thing we can. So we have been building tools to be able to test. Like we have a secondary test net running on different machines with those guys participating also. And there we can modify the software to test it as much as possible.
And this stuff is not theoretical. There are a couple of such bugs, such attacks that exist right now today, and we're waiting for patches for those. And so the thing is, that situation exists fairly frequently. That we play around with it, we find something doesn't look right, investigate, find the bug. We have to responsibly disclose it to Block 1 and get those patches done. So there are two outstanding cases like that now that will be resolved pretty soon.
I would like to add to John's point. EOS, it's a blockchain, but it's still a software. And all the rules of deploying secure software still apply. And so we could learn from industry experience. And, I have deployed systems for Federal Reserve Bank, which are much less critical, in my opinion, than EOS, which went through rigorous security testing and extra precautions taken at infrastructure level. And so we were trying to apply the same principles here for EOS, infrastructure and security best practices. To secure software, you always assume the software is not secure. There are always security holes in any software. So you try to shield it from outside access by extra layers of security. That's just the best practice.
And some of this is pretty hard to deal with because we've got a software supplier who basically believes in testing everything on the live network. And so just to mitigate that, to mitigate also the speed at which the stuff comes out, we've got the Jungle test network. Yep. That is, invaluable for checking the stability and usability of a lot of the features. But we've also now developed our test cave network where we can very rapidly run through all the suites of tests. We've got, over 100 tests that we do on that, fully automated in, less than 15 minutes for any new release. And we're launching now a performance test network where we can tweak and adjust various parameters of the hardware and the software config to look at corner cases.
Great, awesome. And speaking of that, are there any things that we can learn from operational experience of other type of systems of critical infrastructure, like sensitive ICS systems or global financial networks? Richard, I don't know if you can.
So I guess the question is, what can we learn from the way that other kinds of critical infrastructures run? I mean, I think a lot, honestly. To run a block producer at the highest standard is a challenging undertaking. You have, you've got objectives with respect to confidentiality and integrity and availability, and you have to have a systematic planning and thought process. You've got to have done the threat modeling. I think that's key. if you don't start by thinking like an attacker, if you don't make a concerted and serious effort to identify every possible way in which the system could be attacked, in which every way in which your confidentiality objectives could be compromised, so things that should be secret don't stay secret, or ways in which your integrity objectives could be compromised, things that shouldn't be tampered with get tampered with without authorization, and your availability objectives, things that should be working, stop working. If you don't bother to model that out in the beginning, then you're building controls in a vacuum. Then you're trying to solve problems without understanding them first. So probably I think that's, if I had to identify one thing, it would be you can't do effective security in an operational context like this without starting with making a big investment in building the threat models. Folks agree?
Eric?
I would like to add to that. Of course, part of the software we are running is the EOSIO software, but that, of course, comes with running Linux systems, and most of us are using proxies to go into the system and all of those kind of things. So we can, of course, base our best practices on best practices from other systems running on those softwares as well.
Igor?
Yeah, I don't know if you are familiar with, but we have been advocating with a type of infrastructure setup that EOS is just the NodeOne software, EOSIO is just a small part of it, because the producer runs the EOSIO software on the first layer, and we have other layers on top to protect the producer with full nodes that broadcast blocks to all of the network. And beyond that, we have the API nodes that not are always running NodeOS, because now we are using Elasticsearch to improve the API responsiveness instead of using NodeOS, and that's at another, not security, but another concern layers also. So we have to watch the whole picture to see where the threads are.
And of course, some of these software are only there to add to the security, and others are there to add to the uptime that we can provide. So if we add proxies in front of our full nodes, for example, then we can easily take down our full nodes without anything happening to the access to our network.
So one very specific point I would like to bring up is that NodeOS running as a full node has a web server built into it. You can run and accept public connections right into that box. Anybody who's running that is a fool. You should not expose this type of brand new untested software to public access. The potential for security problems or service disruption problems is just way too high. Any full node access should absolutely be proxied by something in front of it that is much more well-known, stable, and certified.
Yeah. Also, if we do that, of course, we can decide if we find a critical issue with some specific call or anything, then we can decide to filter that traffic without modifying the software running in
behind.
That's
easy. And also to add for us, for instance, we are not using HTTPS inside NodeOS anymore because it's not that reliable and breaks performance. So we decided to use EOSIO with HTTP only and use the proxy to provide the secure connection. Also,
I would like to add also, nodes that you see on a EOS monitor page, for example, those are full nodes. You don't see production nodes. Production nodes are actually hidden. Most of us are running on a WireGuard private network where all connections are encrypted point to point between those producing nodes, and there is no access actually to producing node, right? So it's running on a private network. It only has access to synchronized full nodes that it gets blockchain, synchronization from.
That actually brings up a point. We've seen a lot of media or some external surveys who have, tried to look at these block producers, and we see crazy headlines like, everybody's running on AWS and Google Cloud. There's no bare metal block producers. Well, that means that the people doing the measurement don't know what the hell they're doing. Basically, all of us, all of them, are using these web proxies out there, using those cloud services, using other types of services as a way to DDoS protect them or make that easy. The real nodes are actually hidden. Anybody running bare metal is running them in a very hidden way so that you from the public cannot ever know what the actual IP address is, where those physical servers are. That is a proper design. And so anybody doing such a measurement based on the public access, API nodes is always going to see nothing but the proxies. If you can actually see the real production servers, that's a BP that you want to vote down.
Hear, hear.
And just to add to that one more, some of us are running even the proxies on bare metal, and others are not. And that's also good for diversity, in my opinion. So it's very important that we don't all go down the same route, I think. The more we can diversify the network, the better it is.
I agree.
Absolutely.
Yeah, sure. I have another question here. What do you see as the most significant unsolved problems or the biggest current threats in the security of the EOS system right now?
One of the unsolved problems I've been seeing, like recently we have been seeing those huge transaction counts because of testing, most for now. And with that, we noticed that latency between the block transmission on the block producers around the world are not uniform, and they are varying a lot. So one thing that, because right now the schedule is just set in alphabetical order between the producers that are voted on the top 21, and we need some tools to fix this and to actually optimize the schedule to make it faster to move the blocks around. So on that side, we are preparing a tool that we plan to make it public and allow every producer to publish their logs to us. So this will be called Hyperion. Hyperion will be able to collect logs from everyone, and it works in several fronts, but one of the fronts is to build optimized schedule from up position, like an overview from the blockchain. And with that, we'll be able to, for instance, Hyperion should be able to publish a transaction on the blockchain once we have some scheduling tool in the contract. And this transaction, this proposal can be signed by the producers to replace the current schedule with a better schedule that will make the transactions run faster. Because those latency, they can create forks, like not forks of EOS, but forks of the chain, micro forks, and this breaks the performance and cancels some transactions.
So let me expand on that a little bit and simplify it for the less technical folks, because the last few days with these very high transaction volumes, we have seen a shitload of these microforks he's talking about. It's coming from the higher latency that we get when we're seeing these high transaction rates. There are a couple of factors. The factor that we're talking about to try and solve with Hyperion is it's what's called the schedule. We have 21 block producers, and in the system, automatically, we set a schedule, which is the order in which they will produce blocks. That schedule right now is done just purely randomized.
No, alphabetical.
Yeah,
it's just alphabetical.
Yeah. So what we want to do with the Hyperion project is get from each active block producer, get his view of the latency to all the other producers. This is a huge meshing problem, right? Because you've got 21, each is connected to 20, so you've got a 20 factorial data set issue there.
Yeah, and the longer term solution that we're working on is the Hyperion, but we also made some shards where we basically entered our nodes and pinged around to other nodes to make sure how we could optimize the schedule. So we actually have some shards where a lot of us have been involved. And
if we have a solution on the contract to if Block 1 provides something for us to change the schedule manually with a proposal, from a multi-sig proposal, we can just push our manual solution, and I think we'll see great improvement in the transaction performance.
So another big factor in this microforking problem we've seen in the last week or so is how BPs talk to each other. We've got a number of cases where a BP will have a producer node here, they'll have a full node here, the other BP has a producer node which is connected to his full node, and the way they talk to each other is a P2P or BNet connection between their full nodes. Well, when we get these very high transaction rates coming in, the full nodes run a whole lot slower than the producer nodes do. They introduce latency so that getting a block from producer A to producer B, if it has to traverse two full nodes, you're introducing a whole lot of extra latency. And we're seeing in some cases blocks are being held up, they're coming in, 10, 15 seconds later. And every one of those is a disruption and something that has to be recovered.
Let me just add that the software actually managed these mini forks very well. I'm really impressed by the improvements in the NodeOne software.
So yeah, that's the thing. None of this has been a problem so far because the recovery has worked beautifully. But what we want to do is encourage block producers to get more direct connections between the producer nodes, reduce the latency, reduce the variable latency that's introduced by running the flood through the API nodes. And we've got a number of techniques where two producers can connect to each other and never expose their private addresses. So anyone who's interested in doing that, contact one of these guys and we can help set it up.
Okay.
Well, yeah, I just wanted to highlight, a different problem, totally unrelated to that one, but with some similar root causes, which are that we are running a very new software stack here. So let's talk about out-of-band signing for a minute. So in the default configuration, NodeOS is this monolithic thing, and signing happens, which means that private keys have to be accessible within this monolithic piece of software. So Block 1 did something we think is very clever. They gave us this out-of-band signing mechanism so you can farm out the signing process to a separate process that can run in a separate address space. It can be in a different container. It can be in a different server. Unfortunately, the out-of-band signer that they gave us still requires you to have a private key sitting on disk. So we've actually done something that we've open sourced that's available to every block producer who wants it. We've built a different out-of-band signer, one which does not require a private key to be stored in a disk file anyplace. So you can avoid having any private keys stored on any server in your entire block producer infrastructure, that seems like a win.
Oh, that's awesome. Good. Okay, and let me just ask about Hyperion. How's the name? Hyperion.
Yeah.
So you are trying to do it on chain so that block producers will publish the latency between.
No, it's a little more complex than that. So it's Elasticsearch cluster, so it's distributed around the world, and every producer will receive a certificate, a signed TLS certificate emitted from us, so we can actually know that is the real producer, not anyone that just got access to the API and is publishing fake logs, right? So this is one part, the log publishing from the producer, and the software that publishes a log will actually hide the IP address, so we don't know the IP of the producer node. That's fine. And the other part is the collection of the whole blockchain. So Hyperion right now has the complete EOS blockchain indexed in Elasticsearch. So we can provide full analytics about everything that happens on EOS. So if you want to see data from any dApp, we can just give in a couple milliseconds. So, and this enables us to do things that the usual APIs that NodeOS provides don't allow us to do fast, and it will consume resources from the actual node. So instead of consuming resources from the node, we use the query services from Elasticsearch to provide data for anyone that will be able to do it. So these are the two parts, and when this is ready and running, we'll be able to provide more. so we can do alerts for the producers. And since machine learning is coming to this software also, we'll be able to predict some patterns that may bring nodes to crash. So if we see in the past a node crashing due to latency issues or some exceptions that appear on the logs, we might just send alerts to that producer, say, hey, your node has a high probability of crashing today, so something like that.
Okay, that's good. Okay, talking about that, what cross-block producer system and processes do we need that we currently lack, that maybe what you were talking, it's related to that? Like, should we have a shared operational dashboard for early detection of issues and tracks, a more robust incident response plan?
Hell yes.
Actually, this idea came after disaster response planning that Thomas Cox did with the producer, and we got the role of being responsible for monitoring, and then we came to the idea of building this as a platform for the whole community, so it will be serving that purpose.
Right.
Well, and just a question for everybody else on the panel, like what about incident response? I mean, do you guys feel that we have today amongst block producers a sufficiently robust incident response process? We can communicate with each other effectively, we can coordinate our efforts if the stuff hits the fan. Are we good enough at that yet, or do we need to get better?
I feel like we are evolving, right? We are still in the early stages. There are still a lot of improvements that we can do. Again, learning from industry, for example, doing a shared log across active block producers and having a common place to go to monitor for errors across all 21. Something like Splunk or using other tools would be a great addition, and keeping operations stable.
One thing that's problematic about that is comes up clearly. I'd say until about 12 days ago, the top 21 had changed every day. There had been no very consistent set of 21. Almost everyone who's in the top 21 now has been in or out over time. About 12 days ago, it kind of stabilized until Monday this week, and then it started shaking up again. But the point is, you can't have a process that just has some set and say, okay, we know who they are. And the way to evolve a process where sort of the responsible ones change dynamically on any whim is really hard to establish. And we've seen it in the, just sort of the nonsense bitching back and forth about who gets to be in the calls.
Yeah. One idea we've kind of...
Could I just add? Could I add something to this? Thank you. So during the night, we actually had some big accounts hacked. So a lot of EOS was stolen tonight. And so I stayed up for a few hours yesterday and continued this morning. So we have been in communication with all of the block producers within only a few hours. And we actually managed to, I think, everyone has confirmed at least, to stop that attack now. So I think we are getting to a point where we have better access to all of the block producers. And this is even during a conference. So it's, I think it was $1.5 million that we stopped tonight, yeah. That's good.
I mean, I would agree with the perspective that we're getting better. I think there's still some ways to go there. If we're talking about benchmarking ourselves against the kinds of organizations that are the best in the world at this, I think we have some ways still to go.
Yeah, big time. There's a lot of progress to be made here. It's that the encouraging thing is that we're continuously getting better, and we're in the midst here of an incredibly messy bootstrapping of governance. And the block producers are sort of the stable linchpin of this right now, but there's also the ongoing fear of too much power there. So everybody's treading very carefully. Nobody wants to establish too strong a centralized organization that will, then be a magnet for more criticism. So developing this as a distributed system is really a new kind of event. So I'm encouraged that it's getting better. This incident this morning was just lovely. It got done nice and quiet with the right connections to the right people, and it happened. And we're still locked into this tough situation where blacklisting still takes all 21. And we're not to the point where we can do a 15 to 21 multi-sig on it.
And we're also working on that part.
Yeah, of course.
I mean, a related idea that we've just kind of started thinking about and haven't really reached any conclusions on is it may be possible to have some kind of a dynamic permissioning system for who gets notified and who does that is driven by smart contracts on chain.
Yep.
Right? And obviously we'd have to collaborate if we wanted to build a thing.
Yeah, it's definitely the goal to get there. But sort of, in some sense, a lot of these things also need sort of our referendum ability to be in place to, sort of toss out some of the structural changes we might want to make, where it's sometimes better done by a community approval than just a decision amongst BPs. So, there's some are okay here, some really should be here, but we don't have that second option yet. So again, there are a lot of gating factors in this bootstrap. So, but stuff's developing. It's all real positive.
Well, okay, guys, we are running out of time. Maybe if you have some other
there's
things.
one more thing.
One more thing.
Yeah.
Sean, please.
Matías, you forgot to introduce yourself at the beginning.
Yes. Sorry. Well, my name is Matías Romeo. I'm from EOS Argentina. I just joined last week. I have been working for Block One developing EOS for a year. And, well, this is my first time as a moderator, so it's been a pleasure being with you guys and with the audience also.
Thank you,
Thank you very
Matías.
much.
Okay. Right. Well, guys, thank you.
Thank you, gentlemen. That was excellent discussion. Thank you, Jem.